Okay, welcome to Mastermind Scholars Educational Alliance, and we are on checking the probability question bank. So we've done the review questions and we are dealing with the question banks. We have about 9 questions to solve to check our proficiency with probability. So question 1, a student pick a number at random from the set of whole numbers between 5 and 25. Including both 5 and 25 itself. So 25 and 25 is inclusive. What is the probability that the number selected is a multiple of 3 and a multiple of 5? So solution. So we are going to find the probability of multiples of 3. Then we have to find the number of multiples of 3 between 5 and 25. All over the total number of 5 and 25 inclusive. So our probability notation looks like this. That is probability of E. The event is multiple of 3. And then we have to find the number of the event of the multiple of 3 all over the number of the sample space. Then let's look at the multiples of 3. Multiple of 3 between 5 and 25 are 6, 9, 12, 15, 18, 21, 24. And the number of events there, therefore, is 7. When we count, we get 7. When we count, we get 7. Count all of these, we get 7. And then we look at 25. How many sample point or what's the number of the sample point that we have between 5 and 25? Between 5 and 25 inclusive. So 1, 2, 3, 4, 5. You count all of them, you get 21 sample point. So 25 minus 5. You get 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You're going to get 21 for all of them. But if you want to be very snappy, in case numbers get intensified or numbers get large, and you want to find numbers between a particular range with the actual boundary included, then it's easier to find the difference and just add 1. So you find the difference, you add 1, see 21. And when we counted this, we had 21 as well. So that is how to be very snappy finding the difference, the range. When you're asked to find numbers between a particular range with the boundaries included. Take note of that. So our probability becomes 7 over 21. Since the number of events is 7 and the total number of sample point are 21, we get 7 over 21. And that gives us 1 over 3. All right, so let's do a multiple of 5. Now with the multiple of 5, we do the same thing. Number of multiples of 5, this should be 5. No multiples of 3 should be 5. Between 5 and 25. And so we have multiple of 5 is 5, 10, 15, 20, 25. And then we do our sample point again, the total outcome. And that gives us 5 over 21. And so that's it. Let's move on to question 2. A number is randomly selected from a set, and this is a set 4, 7, 10, 13, 16, 19. Find the probability that the number chosen is an even number, an odd number. I greater than 10, even less than 10, then strictly between 4 and 19. Let's check that. So even numbers, we are going to find the number of even numbers over the total number of sets. And that gives us this as a probability notation. Let's find the even numbers there. These are the total sample point. Let's find the even numbers there. 4, 10, 16. And then that gives us 3 out of 6. 1, 2, 3, 4, 5, 6. 3 out of 6. And then we have our final answer to be 1 out of 2. Let's do that same thing for the odd numbers. And odd numbers are 7, 13, 19 from the list we had. And these are the total sample point. You can see 7, 13, 19 being the odd numbers. And then we have 3 over 6, 1 over 2. And that gives us right answer again. Let's look at greater than 10. Greater than 10. So we have greater than 10 are 13, 16, 19 out of this particular sample point. And then we have 3 out of 6 again, 1 out of 2, and that is right. Let's look at less than 10, probability of choosing a number less than 10. Less than 10 from this list, we have 4 out of 7. That will be 2 out of 6. And we have 1 out of 3. And then we get that right as well. Let's look at our last answer. Between 4 and 19, we have number less than should be between 4 and 19, and that will be 7, 10, 13, and then 16. And that gives us this sample point: 4 out of 6, 2 out of 3, and then we have our answer right. Let's go to question 3. There are 100 cars in a park. 28 of them are blue and 34 red. If a car is chosen at random from the cars, what's the probability that it is neither blue nor red? Let's remember, neither blue nor red, it's not any of them. We cannot consider any of them. So we are going to choose numbers that are not blue and not red. Cars that are not blue and not red. So blue cars 28, red cars 34. Neither of them are 38. I added the 2 of them here, subtracted from 100 to get none of them, those who are not blue and red. And then neither blue nor red, number of cars that are neither blue nor red over total number of cars. And then we have number of events is 38. Those that are neither blue nor red are 38. And then the sample points are 100. And then we have 38 over 100. And that gives us 19 over 50. And then we are right. So let's go to question 4. Is it a fair coin is tossed twice? Write down the set of possible outcomes and what is the probability of obtaining exactly 2 heads, no heads, at least 1 head, either a head and a tail. All right. So set of possible outcomes are, we know, writing down the possible outcomes for tossing a coin twice are 4 outcomes: head, 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 tail, tail, head, tail, tail. And that gives us this table. So exactly 2 heads, we are going to see only 1 possible outcome. Let's check that out. Exactly 2 heads, number of outcomes with exactly 2 heads over total outcome. Exactly 2 heads out is just 1. And so we have 1 out of 4. We have the answer right. This side should be NE, not NS. NE, not NS. Sorry for the omission. And we have no head. No head again. So NE is equal to 1. No head is tail, tail. The ones with no head is only tail, tail. That has no head. So tail, tail, that's it. And then we have that 1 out of 4. And then we have answer right. At least 1 head. Let's take note that at least means 1 or more. At least means 1 or more. At least means 1 or more. At least means greater than or equal to. Put that in your head. 1 or more or greater than or equal to. And that gives us 1 or more. So we have this 3 outcomes: head, 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 tail, tail, head. And then that gives us out of 4. So 3 out of 4, we are right. A head and a tail, head, tail, tail, head, 2. And then that's the same thing for this one. We have 1 out of 2. Let's go to question 5. Okay, so question 5. 3 fair coins are tossed once. Write down the set of possible outcomes. B. What is the probability of obtaining I? Exactly 2 heads, I. No tail, I. Not more than 1 head. Let's check the answer out. So solution: possible outcomes for tossing 3 fair coin. We have 8 possible outcomes, which are head, 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 tail, head, tail, head, tail, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. I need you to keep this off head so that you'll be very adept to it. Probability. So exactly 2 heads. Let's get outcomes with exactly 2 heads, and that would be head, head, tail, head, tail, head, tail, head, head. And I think these are the only 3 ones available. You see, that is it here. And then the total outcome is 8 already. So 3 out of 8. We have right. No tail. The only ones with no tail is only head, I guess. So yes. And so 1 out of 8. And then we have not more than one head. It shouldn't be more than one head. It shouldn't be more than one head. So it's only one head. Right. So ones with not more than one head, not more than one head. So one head, or no head. Take that into consideration. Not more than one head. We consider the one with no head as well, which gives us 4. 4 out of, you see, not more than. So I need you to pay very much attention to this side. Not more than and at most means the same thing. So not more than one head means at most one head. So at most is 0 or 1. So take note of that. Many would not consider the TTT as part of it. So we have 4 out of 8, where there's 1 out of 2. Question 6. A coin and a die are thrown at random. Find the probability of getting a head and an even number. B. Getting a head or tail and an odd number. So this sample point, this is going to be the sample point for throwing a coin and a die. You known it already. If you follow the course, everything is fine already. And you combine the die and then the coin. Then the sample point at 12, right? And he's saying getting a head and an even number. So those with the head and even number are going to be this. Head 2, head 4, head 6. These are 3. So 3 out of 12, 1 out of 4 is the answer. Let's look at getting a head or tail and an odd number. So remember, head or tail and an odd number, the head or tail are all outcomes paired with odd number. So we are going to look at head and tail. Head, odd number, and then tail to odd numbers like that. So we are going to get this 1, 3, 5, all heads paired with odd numbers and all tails paired with odd numbers as 6 sample points. And so we have 6 out of 12 and 1 out of 2 to become the answer. Question 7. The table shows 3 classes ABC in a certain school. The 3 classes are put together to select a prefect. What is the probability that the prefect will be a boy, a girl in class B? So when you find tables like this, you need to be very careful. He's asking for a boy to be a prefect from the school. So go to the boys, calculate the total number of boys all over total number of students in the school. So we are going to find the total number of boys and then paired with the total number of students in the school, because that's what it's asking for. Find the probability of that is the prefect will be a boy. So let's calculate the total number of boys and then all over the total number of students in the school to get the probability that the prefect will be a boy. So we have something like this. Total number of boys is 42 from the 3 classes. Total number of girls, 54 from the 3 classes as well. And then total number of students are 96. That is the total of the boys and the girls. So prefect will be a boy. Number of boys in the school all over total number of students. And that gives us 42 over 96, right? 42 over 96, we can cancel that out to become. So yes, that will be 7 out of 16. Check it out with your calculator well and simplify that side. I need to edit my file. And so this same thing happens here. You have 11 over 20, 48. But this time he's asking for the prefect from class B. So what do? Select the student from class B. There's it. That is 22. Class B. All over the total student. All right. So let's go to question 8. And with question 8, a bag contains 12 balls of which X are red. When 18 more balls are added, the probability of selecting a red ball is 9 out of 10. Find the number of red balls that were originally in the bag. So initial balls in the bag are X, right? That are red. And the total balls in the bag are 12. Yeah. So let's add 18 balls to this particular bag. What will happen? All the red balls, we do not know how many red balls there will be, but we know that there will be 18 balls added to the total. So final balls in addition, red becomes x plus 18, the total balls become x plus 12, the 18 plus 12. So it means that the balls have increased, that is the total balls have increased. He said when 18 more red balls, so we added red more 18 more to the x originally in the bag, and that increases the total as well to 30, right? Great. So our probability notation, the number of red balls over the number of total balls will be x plus 18 over 30. That is the number of red balls, x plus 18 over total balls, x, and then 30. Then from our question, you could see that the probability of having a red ball is the same as the notation we have here. That is 9 over 10 will be the same as x over 18 over 30, right? X plus 18 over 30. Doing that, we can equate our work because the probability of a red ball, which is x plus 18 over 30, is the same as 9 over 10. So we do normal algebra by cross multiplying to get this. And then 10x plus 180 is equal to 270. We group like terms to get this, and it becomes 10 over 90. 10x is equal to 90. And then we have divide both sides by 10, and then we have x is equal to 9. So the number of red balls that were originally in the bag are 9. Those were the x balls we didn't find. They are 9. Perfect. Move on to the last question. 3 coins are tossed simultaneously. Write down the sample space S, the number of sample points NS, write down the event A, B, C, and then the number of events in A, the number of outcomes in B, the number of outcomes in C, where A is the event, B is the event of A is the event of getting at least 2 tails, B is the event of getting a head on the middle coin, C event of getting at most 2 head, and then D event of getting no tail. So solution, sample point, these are the sample points of tossing 3 coins simultaneously. And then, so the number of sample point there is n is equal to 8, right? We have that right. So we counted this and we have 8. So now let's move on the event of getting at least 2 tails. So event of getting at least 2 tails is the same as outcomes with 2 or more. I told you earlier that at least means greater than or equal to, right? At least means greater than or equal to. So we have greater than or equal to, so 8 greater than at least 2 tails. So more than 2, it can be 2 tails, can be 3 tails, right? And that is how we have here. And then we have n a is equal to 4. Then event of getting a head on a middle coin. So the middle coin is, let's say, is coin 2. So outcome with h in the middle would be this. You can see all these outcomes have h in the middle. Then we have nb is equal to 4. Event of getting at most 2 head. Remember, at most means that lesser than or equal to. So at most 2 is lesser than or equal to 2, and that is 0 and 1 are included, and we can have this. So either there is no head at all, or there are 2 heads, or there is 1 head, like that. And that is 7 out, and C is equal to 7. The numbers are 7. You count our sample space. The event of getting no tail, only head, and that is our final answer. And that's what we have here. Thank you for joining in for the review questions or question bank. Make sure you go over thoroughly and solve over and over until you are very good with it.